Então, well, that's the way we say hello in Portugal. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of physics. Now, children, this picturesque place that you get to see is Praia da Marina, Caramujera, Portugal. This is one of the finest beaches of Europe, one that has got the Golden Beach Award. Here you will get to do snorkeling, cliff jumping, kayaking, and be in the turquoise waters, always being surrounded by tall orange limestone cliffs. Make sure to have the famous Portuguese food, pão de ló, and also to tell all the people of Portugal that you get to meet Então. In this note, children, let's start off this lecture where today we're going to do more numericals. Make sure to learn all the formulae. If you've yet not subscribed to my channel, make sure to subscribe to my channel. If you're liking it, make sure to click on the like button. Share it to those people who require some help in physics, and make sure to write what next you want me to teach so that next I can start off with that topic in teaching of physics. So now, children, let's get started and let's try out this numerical. So look up the numerical. I'll give you people 10 seconds for trial, after which I'll be discussing the sum in the easiest possible way. Okay. Here, children, the question says a wire of 3 ohm resistance and 10 centimeter length is stretched to 30 centimeter length. Find the new resistance assuming that the cross section when stretched is uniform. So obviously what the question is telling us that there is a wire which has initially been given to you. Remember that a wire is always cylindrical, that means its cross section is circular. When the wire has been stretched, obviously a little of the cross section, especially from the centers, will change. But here we've got to assume that all of that is going to remain to be uniform throughout the wire. Now let's write the data as has been given to us in the question. So here, children, we've been given that the resistance as is initially, we can mark it to be R1, is 3 ohms, right? And further then we've been given that the length of the wire in the first case is 10 centimeter. Then when it is stretched to a length of 30 centimeter, then we've got to find out the resistance in this case. So we will mark it with a question mark. Now, children, quickly remembering the formula, we talk about R to be equal to rho L upon A. I'm sure all of you people have learned this when we discussed it 2 lectures before, right? Next now, children, we'll be discussing about the concept that if we talk about the wire initially or if we talk about the wire after it has been stretched, the volume of the material with the help of which the wire has been made will remain to be the same, or in other words, volume of a cylinder as it is given by V is equal to pi r square h will remain to be the same for both the cases, and thus V1, that is the volume in the first case, will become equal to V2, that is the volume of the second case. Now, keeping the values in this, we will have here pi times of capital R square into say some h will become equal to pi times of small r square times of capital H. Now, of the first case, the length was less and later the length became more. That is how we have the small letter and the capital letter for the lengths. Now, the radius in the earlier case was greater. When it has been stretched, obviously the radius will become lesser, and that's why it has been taken with a small r. Now, next, children, what we can do is here, this is the relation that will be, because the volumes are going to be equal. Now, the common factors are going to be cancelled, that is pi will get cancelled, and here then what we can do is we can now keep the value of r square times of the length of the first case, that is 10, to be equal to r square times of the length of the second case, that is 30. So here 1 power of 10 will get cancelled, and thus we get to see that capital R square is equal to 3 times of small r square. Now this is a relation that we have, which in times to come we will be using. Now next children, we will be talking about the first case, that is we will talk about R1 to be equal to rho times of L1 divided by the first area of cross section, that is A1. Now in this we are going to substitute the values. The resistance as was earlier was 3, so we will keep R1 to be 3, and that's equal to rho, that is the specific resistance, times of the length, which is 10, right? And it is going to be divided by the area of cross section, that is it is pi times of capital R square. So this children is going to become our second equation. Now we talk about the second case, where in the second case we have the resistance which is not known to be R2, and that's equal to the specific resistance times of the length now, that is 30, to be divided by the area of cross section, right? And the area of cross section here will be pi times of small r square. This children is the third equation. Now if we divide the third equation by the second equation, we will now have here R2, and this is divided by 3, which will become equal to rho times of 30 divided by pi times of small r square, whole divided by rho times of 10 divided by pi times of capital R square. Right? Now children, next what we can do is, here as on the right hand side we have one fraction which is divided by another fraction, so we can write this as rho times of 30 upon pi small r square into, or I'll rather increase one more step for better understanding, this can be written as divided by rho times of 10 times of 1 upon pi times of capital R square. Now children, as there is division sign, we can easily convert this to multiplication sign, and then we can write the reciprocal of the fraction which is come next, that is rho times of 30 divided by pi r square into, we have pi capital R square divided by rho times of 10. So 1 power of 10 will get cancelled from the numerator and from the denominator. Rho will also get cancelled, pi will also get cancelled. Now thus we'll be left out with 3, right, which is to be multiplied with capital R square divided by small r square, and that children on the left hand side is equal to R 2 divided by 3. As such, R2 is going to come equal to 3, right, which is going to be multiplied further with 3, and then we will keep the value of r square upon r square. Remember, r square upon r square came out to be how much? It came out from here to be 3, right? So capital R square divided by small r square is 3. That is the value that we keep here. So the resistance of the second case will come to 27 ohm, which is thus the final answer. So children, now I'll just quickly discuss the sum all over. In the question, you've been given here that there is a wire of resistance 3 ohm and of length 10 centimeter. It is stretched to 30 centimeter length. That means its length after being pulled becomes 30 centimeter. Now earlier, if the resistance was 3 ohm, you've got to find out the new resistance, right? So we register all the data. R1 resistance, the first case is 3, length is 10 centimeter. Length of the second case is 30 centimeter when we require the resistance, that is R2 is 1, which has been questioned. So as R is equal to rho L upon A, right, this is the formula which is going to be used. We will now proceed with this formula, but first we will be discussing about the stretching of the wire, where on stretching the volume of the wire will remain to be the same. Earlier, if the volume of the metal was say some X, later also it will remain to be X, because the wire has been stretched, it has not been cut up into some parts. Okay, so as the wire always is cylindrical, so the volume will be pi r square h. Volume of the first case will become equal to the volume of the second case. Of the first case, it is pi times of capital R square into h. That will become equal to pi times of small r square into h. Here pi will get cancelled. We have the length of the first case, which is 10, and length of the second case, which is 30. Here 1 power of 10 will get cancelled. As such, we will get capital R square, that is the radius square of the first case, to be equal to 3 times the radius square of the second case. This in times to come we are going to use. Now we talk about the first case, where the resistance will become equal to rho times of length L1 divided by the area of cross section 1. Now as the length was 10 and the area of cross section was pi r square, so we substitute these values and write it to be equation number 2. Then we come over to case 2, where the resistance is equal to rho times of 30 upon pi r square, right, as the length had been increased to 30 and the area of cross section was pi times of small r square. Now when we divide the third equation by the second equation, we will get r2 to be divided by 3. That will become equal to, here, this fraction to be divided by this fraction. So we have rho times of 30 upon pi r square divided by rho times of 10 upon pi capital R square. Now children, as this is one fraction which is divided by another fraction, we can write it something like this. And then as the division sign can be converted to multiplication sign, so we will do that, and then the fraction which comes after it, we have to write the reciprocal of it, so that will be pi times of capital R square divided by rho times of 10. Now 1 power of 10 will get cancelled from the numerator and from the denominator. Rho will get cancelled, and then further pi also will get cancelled, and thus we are left out with 3 times of capital R square divided by r square. Now we will remember from the earlier relation that we got in equation number 1 that capital R square divided by small r square can be written to be 3. So this value is what we can write here, right? So we have this 3, and then the 3 that we have in the denominator will get cross multiplied to the numerator as 3 here, and except that we also have this 3 which was here. So this 3 into this 3 into the value 3, which is of capital R square upon small r square, will all get multiplied to give us 27 ohm, which is the resistance of the new stretched wire. Is this clear with everybody? For sure.